Hello and welcome to IB and A-Level Learning Center with Mr. Taifan, and this is a video about AP Statistic. AP Statistic. In this video, I'm going to help you to solve the problems in the free response question part in May 2023. As you can see here, I have the free response questions with the provided formulas on the pages on the sheet, and we're going to use these formula to solve the problems, of course. Let's start with the question 1 here. The time for this free response part is 1 hour and 5 minutes, and it involves 5 questions. Question 1. A part of a study on the chemistry of Alaskan streams. Researchers took water samples from many streams with temperatures colder than 8 degrees and from many streams with a temperature warmer than 8 degrees Celsius. Đây là một phần của một cái nghiên cứu về hóa học về những cái dòng suối, dòng sông. Stream này chắc là dòng suối, tại vì river mới là sông ở Alaska. Và những cái người nghiên cứu này lấy những cái mẫu nước từ nhiều cái dòng suối khác nhau với nhiệt độ thấp hơn 8 độ C và những cái mẫu khác với nhiệt độ là ấm hơn 8 độ C. For each sample, the researcher measured the dissolved oxygen concentration in milligrams per liter. Với mỗi cái mẫu nước này thì người ta sẽ đo cái nồng độ oxy hòa tan, dissolved oxygen concentration, với cái unit đơn vị là milligrams trên mỗi ml. Thì ở đây chúng ta có một cái histogram. We have a histogram here when the horizontal quantity is the dissolved oxygen concentration measured in milligrams per liter in streams with the temperatures colder than 8 degrees. Lưu ý là ở đây nhiệt độ của cái histogram này là nhỏ hơn là 8 độ C, colder than 8 degrees. The researcher construct a histogram shown for the dissolved oxygen concentration in streams from the sample with water temperatures colder than 8 degrees. Based on the histogram, describe the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 degrees. Rồi câu đầu tiên này người ta bảo mình phải viết ra những cái sự mô tả của mình. Mình describe cái histogram này in stream water temperature. Và histogram này nhắc lại là nó chỉ dành cho cái nhiệt độ thấp hơn 8 độ C thôi. So when describing a histogram, we need to describe these following things. Firstly, let me try reducing the service text. Okay, so we need to describe the mean, the symmetry of this histogram. Is it symmetric or not? Is it symmetric or normal or skewed? Meaning, is it symmetry or skewed? Okay, the skewness. That is the first thing. Secondly, the mean. How can we estimate the mean or calculate the mean using a calculator? The spread of the data, it is a widely spread distribution or a narrow distribution, and lastly the outliers, if they exist, the outlier in this distribution. So we can see that this distribution is a little bit symmetric. For this part here, is a little bit kinda symmetric here, but not actually symmetric, because we see that it has a long tail on this side, a long tail, and it even have the two value here, one sample with the dissolved oxygen concentration from 2 to 3 millimeter per gram, and one sample having the concentration from 4 to 5 milligram. So it has a long tail here, and therefore we say that this distribution is left skewed. Mình thấy cái phân bố này nó không có đối xứng, nó không có normal, mà nó bị lệch ở phía bên phải. Nói cách khác là nó có một cái đuôi dài ở bên trái, cho nên mình gọi nó là left skewed. Và nhìn vào distribution này thì tại vì nó cũng hơi có cái sự đối xứng ở chỗ này, cho nên mình sẽ guess rằng cái mean của mình nó sẽ nằm trong cái column này và nó sẽ hơi lệch phía bên trái, nghĩa là tôi đoán rằng cái mean nó sẽ nằm ở đây. I can make an assumption that the mean is somewhere near the value 11, but to be certain about the mean value, I can put the values of the concentration and the frequency in a calculator to find the mean. Okay, here how we can use a calculator to find that the mean as well as the lower quartile, upper quartile, the interquartile range of this histogram using this TI-84 calculator. Okay, turn it on, go to the start menu here, statistic, start menu. Okay, then go to the edit, meaning we will enter the value to the list. The first list will be the value, and the second list will be the frequency. So the first list, the value from 2 to 3. I need to take the midpoint, the middle value of 2 to 3, which means 2.5. Similarly, for the next column here, I need to take 4.5, which is the midpoint of this range, this interval from 4 to 5. And similarly, with other column, 6.5, 7.5, 8.5, 9.5, 10.5, 1. Oh, there's a one missing value here. Delete that thing. Okay, 13, 12, 15, 40, 94, not 98, sorry, 94, 177, 117, and 89, and 46. So we need to be very careful when entering the value of the frequency and the midpoint value in this histogram. Okay, so I've just completed entering the value in the calculator. The next thing, I go to the start, calculate one variable start. One variable start. The list is the frequency list is the second list, so I need to enter the second list here. Go to the second function here so that we can choose the list in the blue color, the list number 2. Okay, that's it. Then this is the result. So we have the mean of 1109, approximately 11.1. That is the mean of x, x bar, or sometimes denoted by the letter mu, about 11.1. So it's very close to my approximation I told you earlier, right? And standard deviation. Okay, you need to find the Q1, Q2, and Q3. Q1 is 10.5. Q1 is 10.5 milligram per liter, and then Q3, the upper quartile, and we need the median also. So let me write Q3 first before mentioning Q2. Q3 is 12.5. 12.5, of course, give you the same milligram per liter. And Q2, the median, I want to find it too. Median here, 11.5. 11.5 milligram per liter. So we can also determine the interquartile range, which is simply the difference between the Q3 and Q1. Okay, interquartile range. Q3 is 12.5 and minus Q1 10.5. 12.5 minus 10.5, of course, so the interquartile range is simply 2.0 milligram per liter. And lastly, outlier. A value is an outlier when that value is different from the Q1 or the Q3, greater than 1.5 times the interquartile range. Interquartile range is 2, the low quartile is 10.5. Therefore, a value is outlier when it is smaller than, let me write up here, for the outliers. Those outliers must be smaller than the 10.5 lower quartile minus 1.5 times interquartile range, which is 2, and therefore that value is 10.5 minus 1.5 times interquartile range is 2, 7.5. A value is outlier when it's smaller than 7.5 or is greater than the upper quartile plus the 1.5 times the interquartile range. 12.5 is the upper quartile plus 1.5 times of interquartile range 2, so 15.5. 15.5, and we do not have the 15.5 value, but there are some outlier here from 6.5, from 7.5 here. So these values are the outliers in our distributions. So fix the explanation. Write your answer in the form of a paragraph. Okay. Mình sẽ tự viết lại mấy cái này ở dạng paragraph nha. Mình có thể viết kiểu list ra. The histogram is left skewed. There are some outlier on the left side of the distribution, and then mentioning these central tendency values, mean, low quartile, upper quartile, and the median. Okay, that is the solution for the question 1A. Let's move on to the question B. Now we are given here another table. The researcher computed summary statistics shown in the table above here for the dissolved oxygen concentration in the stream for the samples with the water temperature warmer than 8 degrees. Bây giờ thì đây là một cái table khác với cái dữ liệu của mình là những cái dòng suối nó có nhiệt độ nước lớn hơn 8 độ C nhé. Nó khác với cái dữ liệu cũ. Use the summary statistic to construct a box plot for the dissolved oxygen concentration in streams with the water temperature warmer than 8 degrees. Do not indicate outliers. Rồi, cái nhiệm vụ của mình là vẽ một cái box plot thôi. Thì box plot thì mình phải có mấy cái thông tin này thì mình có hết rồi. Median, Q1, Q3. So the median is 5.43. 5.43 approximately equal to 5.5. 5.43 is like here. Okay, we change the color. 5.43 here is the median. Then we need the upper quartile, Q3. Upper quartile is 6.12. 6.5 here, 6.12 here. There. And then the lower quartile is about 4.4. 4.5 here, 4.4 is very close. So this is the first box that we have. Q2 here, Q1 here, Q3 here. And 50% of the data is in this range from the lower quartile to the upper quartile. For example, we have 100 samples, then 50 samples among that 100 samples will be in the range here from lower quartile to upper quartile. The maximum is 13.45. 13 here, 45, very close to 13.5, very close. Okay, so this is the box plot. And the minimum is 2.1, a little bit greater than 2 there. So this is our whisker plot, the minimum here and the maximum here, done. And we can see that because 50% of data is in this range, the rectangular box here, therefore the mean of this data will be quite close. In this next range, this range have 25% of data. This range from the Q1 to the minimum involve 25%. So the medium, the mean is also close to the Q2, and the distance here between Q3 and Q2, this region is smaller. It has smaller area compared to this one, meaning 25% of the value focus of this region. So the mean will be close to Q2 too. Close to Q2. The mean is like here. The mean is like here, at this point. Okay, that is my estimation. Or if I'm not so certain about that mean, I can estimate that the mean is somewhere from the low quartile to the upper quartile, meaning from 4.39 to 6.12. Anyway, that mean is definitely smaller than the mean of the sample in the previous case when the temperature is colder than 8. The mean here is 11.1. Okay, and the mean for the new data table here is somewhere from the low quartile 4.39 to 6.12, and my estimation is like here, about 5.5, approximately 5.5. So that's definitely smaller than the mean in the previous temperature when the temperature is smaller than 8 degrees. Okay. The question C. The researcher believed that the streams with higher dissolved oxygen concentration are generally healthier for wildlife. Which streams are generally healthier for wildlife? Those with the water temperature colder than 8 degrees or those with the water temperature warmer than 8 degrees? Using characteristic of the distribution of dissolved oxygen concentration for the temperature colder than 8 degrees and the characteristic of the distribution of dissolved oxygen concentration for temperatures warmer than 8 degrees, justify your answer. Người ta hỏi là dựa vào hai cái bộ data này, đặc biệt là những cái tính chất của hai bộ data này, hãy đưa ra nhận xét rằng là cái loại nước nào nhiệt độ cao hơn 8 độ C hay thấp hơn 8 độ C thì tốt hơn cho đời sống của các loài sinh vật wildlife trong tự nhiên. Sử dụng những tính chất để cho của hai cái data table này hay là cái whisker plot này. Và một thông tin rất là quan trọng trong bài này đó là cái the higher the dissolved oxygen level here, khi mà cái nồng độ oxy hòa tan trong cái nước đó nó cao hơn thì nó tốt hơn, healthier. Đó. Như vậy chúng ta thấy rằng cái mean của cái bộ data đầu tiên này với nhiệt độ nước thấp hơn 8 độ C thì nó cao hơn so với cái mean dissolved oxygen concentration của những cái nước nó có nhiệt độ thấp hơn 8 độ C. Do đó cho nên chúng ta sẽ chọn là những cái nước nó có nhiệt độ thấp hơn 8 độ C thì tốt hơn ha. So this is our final answer. The sample of the water, okay, the sample of water with the temperature lower than 8 degree, lower than 8 degree is healthier for the wildlife, because they have higher dissolved oxygen concentration level, oxygen concentration according to the characteristic of the table, which mean 11.1 compared to greater than about 5.5. This is additional information, okay? According to the characteristic of the two sample result, characteristic of the samples. Done. So that is the solution for the question 1, huh? So you can see that the first one here is the most important one, and you should use a calculator to have the accurate value of the mean Q1, Q2, and Q3. Thank you, and we will see you again on the next question.